Alright guys, so in this video, I'm going to prove deductively that this is true. Tangent theta is equal to sine theta over cosine theta. So notice I have the same diagram as in the previous video for the Pythagorean trig identity. I have a right triangle with theta, x, y, and r labeled. Okay? So am I going to want to start off with an equation involving the Pythagorean theorem, like x squared plus y squared is equal to r squared? Well, no, because the Pythagorean equation has nothing to do with my final solution. This is where I want to get to. I want to get to tangent theta is equal to sine theta over cosine theta. So, but what would be wise is to start off with an expression, a general expression, an equation about tangent of theta. So what is tangent theta equal to? So once again, we're not going to look at the final solution. We're not going to look at where we're trying to get to. We're only focusing on the diagram. So tangent theta is equal to opposite over adjacent, which in this case is y over x. Now from the previous tutorial video, we know that y is equal to r sine theta. And we also know that x is equal to r cosine theta. If you have forgotten where these two come from, you can look at the previous video, and that should help you out. So now I have everything I need in order to do some substitution. Notice I have a y and an x in my first equation, and I know what y is equal to in terms of sine, and I know what x is equal to in terms of cosine. So I'm going to take this y and this x and what they're equal to and substitute them into my first equation. So we get that the tangent of theta is equal to, instead of writing y, I'm going to write what y is actually equal to, r times sine theta. And we know that x is equal to r cosine theta. And what happens to these r's over here? Well, we know algebraically that they're just going to cancel out. R divided by r is just 1. So tangent theta is equal to sine theta over cosine theta. And that's exactly what I want.